Now we're going to be looking at what if I have absolute value in both cases. All right, so we're going to start with saying z plus 6 is equal to 2z minus 3. And then I'm also going to say that z plus 6 is equal to the negative of 2z minus 3. Notice I put my second absolute value in parentheses and I call the negative of that. That's how I'm going to split it. Let me work my first one. I have z's on both sides, so let me bring the z's to the left. Negative 2z. Let me bring my 6 to the right, to negative 6. So I have that negative z is equal to negative 9. We're going to say that z must be equal to 9. Looking at the second equation, let me distribute the negative sign first. So z plus 6 is equal to negative 2z plus 3, because I distribute the negative sign. Let me bring the 2z to the left. Let me bring my minus 6 to the right. So I have that 3z is equal to negative 3. Divide both sides by 3. And z, in this case, is equal to negative 1. Now, the cool thing on this, we're going to talk about absolute value. The cool thing of absolute value is whatever you have on the inside, make it positive. Now, here it says we have a positive value because it has the absolute value of it. We have a positive value. When is a positive equal to negative 4? Well, never, because the absolute value is positive. So it can never be equal to a negative. So we're going to call this no solution. No matter what value of art I can think of, it's not going to work. Or the way we also say it is the solution set, the interval notation. I have my brackets here, and I say I'm not going to have anything because there's no solution. So empty is shown as a 0 with a slash. That means it's empty. There's no solution. Now, looking at example B, absolute value equal to 0. That will be true if 7x minus 3 is equal to 0 to begin with, because the absolute value of 0 is 0. So when it is equal to 0, we can work on this. I'm just going to add 3 to both sides. 7x is equal to 3. So x must be 3 divided by 7. We can work an absolute value equal to 0, but we cannot do an absolute value equal to negative. So here, this other example, an absolute value being greater than a negative number. I know absolute value is positive, so greater than a negative, that will always be true. We have known this as infinite. One way we have seen this before is infinite many solutions. Or the way we do is an interval notation. I'm going to say, think of any value as far left as negative infinity and as far right as positive infinity. Anything in between. Basically, any number. Now, looking at question B, let me get the absolute value by itself first. So I'm going to add 3 to both sides. So I have the absolute value of x plus 6 is less than negative 2. I know an absolute value is positive. Now, a positive value being less than a negative, no solution. Or my solution set is empty. Now, looking at example C, let me get the absolute value by itself. So let me subtract 4 from each side. X minus 7 is less than or equal to 0. Now, this statement is very important though. Less than or equal to. So what I have is absolute value of x minus 7 is less than 0, or absolute value of x minus 7 is equal to 0. That's what I mean, less than or equal to. I know less than will not give me an answer because an absolute value cannot be less than 0. So that's not going to give me anything. But x minus 7 equal to 0, yeah, I can do that. I'm just going to say x minus 7 is equal to 0. Add 7 to both sides. X in this case is 7.